Hello, hi all, after a long time. So today's topic is resonance, right? So forget about this. I just start from the beginning. So the resonance is categorized in different way. One is physics and another is in chemistry. So in physics is called the increase of amplitude in terms of frequency, right? As you all know, with increasing the frequency, the amplitude get increased, and we have a lot of example in day-to-day life. On the other hand, in chemistry, we always say the resonance factor because depending on this factor, all this kind of reaction is happening in chemistry. So what is the major prime of interest, this resonance? In chemistry, in resonance called the delocalization of electrons, and the structure is referred as a canonical form or called the canonical structure. So if you go in your book, you can see that it has already written this kind of CO3 structure. But before I proceed that, I thought that I just write the resonance structure and also tell you something about this structure, how it comes out. You know, these things, the CO3, how it comes out. So CO3 is actually comes out from potassium carbonate when it's get dissociate, and it forms like 2K plus and CO3 2 minus, and this CO3 2 minus is written in your book. So before you write this structure, you need to know how it comes out, right? So now you can know that potassium carbonate, it is dissociate and it gives the carbonate anions, and this anions is written in your book. Now you can see what is happening actually, why the molecules goes in different structural forms. Because if you write this structure, the carbon is center and the three oxygens are in different position. Now you can see there are two negative charge, right? So what happened if this electronegative oxygens pulled the electron towards itself? Then what is happen? The next stage, the carbon center gets positively charged. And when the carbon center is positively charged, it becomes neutralized. How it's neutralized? The anions moves from oxygen center to the carbon center. So that's why I have written this intermediate structure, but you cannot find this in your book because this is the intermediate structure. This is, that's why I have written this way. This is the intermediate, and this is proved by spectroscopically all the structure. So now here in the second structure, what you will get in your book, it's written like this way. So if you can see from here, this oxygen gives the negatively charged, carbon become positive, and then this oxygen pulled out the all this electron from carbon center. So what will be the next structure? Like this will be the double bond. It comes out here, and if the oxygen pulled all this electron towards itself, then it gets negatively charged, right? And in the same way, this oxygens gives the electron to the carbon center, and then these oxygens pulled out the electron towards itself. So there are three canonical structure is written here, 1, 2 and 3, right? And I can also show you the another structure which is called the equilibrium structure, where you can get, people are also referred in this way, is written like OOO, and due to all this pi electron delocalization, it will be written in this way also, right? Okay, because these electrons are localized throughout this all this center, like carbon to oxygen center, that's why it's written in this way, the sigma bond and pi electron delocalization. Next, the second example is NO2. So what happened in the NO2? I've written the structure N, and then double bond O, and then another oxygen is always pulled out the electron towards itself, and then this oxygen gives the electron towards the nitrogen center. So now the nitrogen center is much more electronic rich. So what happened, this oxygen then take out all these extra electrons from the nitrogen center. So there are two canonical form, right? You can also write this one N, and then O, and then O, and this should be like this, right? Then do you know this what is called? This is called the thiocyanate. So thiocyanate is double bond C and double bond N. Here you can see that carbon is valency is 4, it's fully filled up, and then what happened, the nitrogen is much more electronegative, it's take out the electron. So what happened is this nitrogen gives the electron to the carbon center. Now the sulfur becomes negatively charged. So the next canonical form I have written in this way. Here it is the triple bond, and due to sulfur pulled the electron, it becomes negatively charged, right? The fourth example is this. So what happened, this is called the ozone, is found in atmosphere, right, which is called the ozonosphere, and this ozone is also goes different canonical structure. So O3, oxygen double bond O, and then another oxygen. So what happened, this oxygen center is negatively charged because it has highly electron rich center, and this is less electron rich center. So what happened, this will gives the electron in this oxygen center, and this oxygen becomes much more negative because it pulled out all this electron towards itself. So now this becomes negatively charged and this becomes double bond, right? Here I have shown you this way. The another example is benzene, which is written also in your book. You can find it's very easy. Here the pi electron delocalization. What happened for this kind of complicated structure? You can write 1 2 3, 1 2 3 4 5 6. So this is the 6-membered ring, and you can find that after delocalization how the pi electron gets changed. So 1 2 position, and then 3 4 position, 5 6 position, these pi electron are present. So what happened, if the pi electron comes out in 2 position, then 1 position gets positively charged and 2 position is negatively charged. Now this electron moves to the 3 position and 3 electron goes to the 4 position. In this way it will go change the position. So now you can see from the first structure in 1 2 position double bond, but after all this circulation it goes changes. You can find 1 2 3 4 5 and the 6. So what happened, in this previous structure you have seen 1 2 position, here is 2 3 position, here the previous structure 3 4 position, after resonance it goes 4 5 position, and the 5 6 position there is a pi electron, and you can 6 6 1 position the pi electron, right? And finally I have shown you another example. You can also ask me that you have shown all this electronic delocalization where the negatively charged move, but is it possible to move the positive charge? Of course. Here is an example like CH2 double bond CH bond CH2 is plus. So what happened, this carbon center gets positively charged and this pi electron moves to here. Now this carbons becomes positively charged, right? It becomes much more cationic, and here the double bond is generated. So now this true form is movement of positive charge, right? So what is the importance of this resonance? Why we should know this resonance structure? Because it is very important to understand the different formation of the molecules, and after reaction in which position which groups is easily come, and what site of reaction is goes in organic synthesis is very important to understand the resonance, right? Sometimes we will get in benzene, let's say in benzene, that here any side groups is comes out, or whether here any side groups is comes out. So how we can predict the reactivity of the ring? So that's why we need to know where the charge goes moves. So depending on the charge movement, we can easily predict the structure and the reactivity ratio, right? I'll tell you later as well. So for today's these things, see you next time. Bye.